Okay, I'm going to give a little demo of accessing some cloud-optimized data from the National Water Model from Amazon's public data program using the Pangeo deployment on USGS CHS. So the first thing to do if you haven't used Pangeo on CHS is go to code.chs.usgs.gov and you can search there for, you should be able to search for Pangeo tutorial. And you see some different versions here that people have, but you want this one that's Pangeo Notebooks, Pangeo tutorial. Okay, so we select that. And there's a README in here that explains how to run this tutorial on CHS. So if you go down here to this part, it leads you through signing up for Pangeo, and then it gives some more information in here, including this little bit, additional repos that work with CHS are at this location here, Pangeo Notebooks. So this is actually where we're going to find this example National Water Model Notebook. You can see it's right here. Okay. So if we go here, we can clone the repo. So copy the URL, and then when we log into pangeo.chs.usgs.gov, we come up with this default interface here. There's a little launcher here, and on the launcher there's a terminal, so we can open up the terminal, and then we can do git, well, we can just drop that. Okay, actually we need to do, oops, we need to do git clone, oops, maybe just one T on that, git clone, to clone that repo. And then we should see this repo in the file browser over here. If we maybe refresh it, and here it is, National Water Model, and here's this notebook. So we open up the notebook, and let's go ahead and clear all the output. So we start off with a clean notebook, and let's just step through here. So we import some packages. Now we start a DAS cluster. We're going to start on CHS. It's a Kubernetes cluster. There's a lot of different ways to start a cluster. And right, the workers are coming in here. This can take some time if nobody's spun up a cluster recently, but here it was pretty fast because I've been using this. So now we attach a client to the cluster, a DAS client, and now we can go to a URL that contains this public data set. This is a bucket that contains this public data set. We can open it up with Xarray. We can say open Zarr, give it that URL, tell it it's anonymous, and that it has consolidated metadata, loads just the metadata in 3 seconds. And then we can look at a particular variable here, like stream flow, and we can see that it has 227,000 time values and 2.7 million different rivers. The whole total size of this data in memory would be 5 terabytes, but it's been chunked into little pieces that have 672 in the time dimension and 30,000 in the feature ID or the stream location river gauge, virtual river gauge dimension. And each one of those is about 160 megabytes. So if you wanted to load all this, it would you'd have 30,000, over 30,000 tasks to load all those. So obviously that works better if you have a bunch of cores. Each core can do some of those tasks. Let's just confirm here, yeah, that it's 5 terabytes. Yeah, so we don't really need that. We can delete that one. So okay, so let's do something. Let's actually load some data. We've only loaded metadata so far. But before we do that, let's open up this little dashboard button over here, and we can, if this isn't already populated, if it just is blank, you can usually do a search and find what the dashboard URL is, or you can just drag this into the space up here. So there's lots of different ways we can look at what's going on. I usually like to look at the progress and the task stream. So I'm going to click that, and I'm going to click the progress, and I'm going to drag them over actually to the right-hand side here. So I'm going to put my task stream here. I'm going to put my progress bar below it, and then I'm going to make a little more real estate here for the actual notebook by closing this down. Let's make it even a little bit. Let's go like that. All right, so we got our cluster. We've got our little dashboard over here, so we can see what the cluster is actually doing. So let's actually do something now. Let's go in and find the site. So we're going to do that particular variable streamflow, and we're going to select a particular time, and we're going to find out which has the maximum streamflow. Okay, so from those 2.7 million rivers. So when I hit this, it actually has to go do some work. It actually has to load 91 chunks of data. You can see it, what's going on up here. The different workers now are kicking in, and they're all reading little chunks of data to find out which river has the maximum. Okay, so so we did that. It took 17 seconds. We found this particular index, and now we can go into that index and extract all the time values for the entire 18 years, right? So we're going to say grid. We're going to go ahead and just plot that up. You can see it working again now. It's loading 340 chunks of data, and in just 3.5 seconds, we have the entire streamflow record from that particular site. All right, so let's go ahead and now compute the mean discharge on all the rivers during the entire year of 2017. So we're going to again select streamflow, and we can come in and just slice here with xarray. We can just say a slice from start to stop, from the beginning of 2017 to the end of 2017. And let's see how big that thing is. That's going to be 200 gigabytes of data we're reading. And let's go ahead and compute. And so again, we have about 1,200 tasks here on these of reading the data, a total of 4,000 tasks, but armed with our 60 workers, this all happens rather speedily. So in just about 20 seconds or so, we can read the entire year's worth of data and compute the mean. And just to make sure that we actually got something that looks reasonable, we can plot it up. And there we go. There's the mean streamflow for 2017, and we can go in and we can actually zoom with these little tools. And so if we wanted to see what's going on here, we can zoom in and we can pan around. And actually, if we wanted to turn the hover tool on, we can see what some of these values are. All right. And then at the end, to be nice doobies, we close down the client that we've attached to the cluster, and we close down the cluster so those resources aren't